As mentioned in the beginning of this video, we will learn on how to sketch quadratic surfaces of 2 and 3 variables. Now, we want to learn on how to sketch quadratic surfaces of 2 variables. There are few types of quadratic surfaces of 2 variables, such as plane and cylindrical surfaces. Let's put our attention to sketch quadratic surfaces which represent plane. As you can see from the slide, the question asks you to sketch x is equal to 4 in 3-dimensional coordinate system. You have to always bear in your mind, when it comes to 3-dimensional coordinate system, it comprises of all 3 axes, which we call them as x-axis, y-axis, and z-axis. In this particular question, you are given with a mathematical expression x is equal to 4. Okay, let me sketch the axis first. Z-axis, y, and x-axis. As you can see from the axis, you have 3 variables that you need to consider, x, y, and z. But in this case, you are given only an equation that has information of x is equal to 4. Alright, when you try to tackle this question, or this is your first time encounter such problem, you have to be able to visualize x is equal to 4 in 2-dimensional coordinate first. Okay, because by understanding how it looks like in 2-dimensional coordinate system, it will help you when you try to sketch x is equal to 4 in 3-dimensional coordinate system. Okay, so this is 3D. Now, this is 2D. Consists of y and x. X is equal to 4 in 2-dimensional coordinate system is a vertical line because you fix the value x at x is equal to 4 and you allow y to varies. For example, this is x is equal to 4, a vertical line in 2-dimensional coordinate system. As you can see from here, when you try to illustrate x is equal to 4, you will see that you will end up having a line which is parallel to the missing variable in the equation, such as 2-dimensional coordinate system involve x and y variables. X is equal to 4, there is no variable y in the equation which is x is equal to 4. Then we will allow y to varies, and at the same time we fix the value of x. Here comes the term arbitrary, such as y can be any value. For example, if I'm asking you to determine points that lies along line x is equal to 4, you can simply say for 1, for 4, for 7, for negative 2, even for negative 100. Because it will always lies along line x is equal to 4. So this information is very crucial when you try to illustrate it in 3-dimensional coordinate system. As you can see from the screen, we have to locate first where is x is equal to 4. So this is the location for x is equal to 4. And according to what I have explained in 2-dimensional coordinate system, if the variable is missing, you can simply say that the value for that missing variable is arbitrary, which is you allow it to be any value. So in this case, when we talk about 3-dimensional coordinate system, so if the missing variables are y and z, you can safely assume the value for y and z are arbitrary. In this case, you will see that you will end up with a plane which will be traced along the missing variable or parallel to the missing variable. So if this is x is equal to 4, you have to find or search the line to the missing variable. So in this case, I will know that this is the dotted line represent line that is parallel to variable z, and then I can have another dotted line, but this time around the dotted line will be parallel to the missing variable y. So by using the power of imagination, I will know that I will end up with this type of plane, and this plane obviously will be traced along the missing variables, which are y and z. So let me put some shaded over here. Okay. Alright. So that's how you sketch plane in two-dimensional coordinate system. Now, let's discuss on how we can sketch y is equal to 2x minus 3 in three-dimensional coordinate system. But in this particular question, the author asks you to sketch y is equal to 2x minus 3 in two-dimensional coordinate system first, and then followed by three-dimensional coordinate system. Alright. And then right now, I'm trying to sketch two axes in two-dimensional coordinate system that involve y and x. Alright, I will know for sure that y is equal to 2x minus 3. What should I do? I have to determine x and y intercept. So in this case, by letting x is equal to 0, y is equal to negative 3. And by letting y is equal to 0, x is equal to 3 over 2. So right now, maybe 3 over 2 is somewhere over here. 3 over 2. Meanwhile, y is equal to negative 3, maybe somewhere over here. So I will end up having this straight line in two-dimensional coordinate system. Alright. Now, let's focus our attention to three-dimensional coordinate system. Okay, I did explain in the previous example, when you try to sketch 3D, your capability to illustrate the equation in two-dimensional coordinate system will help you a lot when you try to sketch the equation in three-dimensional coordinate system. Okay, don't forget that. But if you do a lot of exercises, by right you will know by your heart that when you have this particular equation, it will give you this type of surfaces in three-dimensional coordinate system. You don't have to sketch it in 2D and then followed by 3D, because if you do a lot of exercises, as mentioned earlier, you should be able to sketch 3D surfaces all the way. Alright, so in this case, I have to locate 3 over 2 in this particular question. Maybe this is 3 over 2, and y is equal to negative 3 is maybe somewhere over here, and then I will end up with a line. Wait, yeah, I try to improve my figure. Okay, this is y is equal to 2x minus 3. Alright, as mentioned earlier, since there is no variable z, you can say that this particular plane will be traced along the missing variables, which in this case is z-axis. So I will end up sketching a dotted line, and this dotted line will be traced or parallel along z-axis. So I will end up getting something like this. Then if I try to improve the figure, okay, so let me put some shaded over here so that you can see how the plane is formed clearly. Right? So y is equal to 2x minus 3 will give you a plane in three-dimensional coordinate system, and this plane will be traced along variable z or z-axis since there is no variable z in the given equation, which means z is arbitrary, z can be any value. Alright, so this is how you sketch y is equal to 2x minus 3. In the beginning of the video, I did mention there are few types of quadric surfaces. The one that we have discussed earlier is called plane, and right now we would like to put our attention on how to sketch another type of quadric surfaces of two variables, which is cylinder. This is the general equation that represents cylinder. Alright, let's go straight away to the class activity where you are given with x squared plus y squared is equal to 4. You can see from here, when the value of A is equal to value of B, you will end up with this equation, and in two-dimensional coordinate system, you will end up with a circle with radius 2. But if the question asks you to sketch x squared plus y squared is equal to 4 in two-dimensional coordinate system, you will end up with circle. But in three-dimensional coordinate system, we will call it as cylinder. Alright, so let's try to sketch in two-dimensional coordinate system first, because it will help us a lot when we try to project it on three-dimensional coordinate system. Okay, in 2D, as mentioned earlier, you will end up with a circle with radius 2. But in three-dimensional coordinate system, you will see that you will end up having a circle on xy plane. Okay, let me sketch the base first. And then in this expression, x squared plus y squared is equal to 4, there is no variable z. According to our understanding, if this happen, we can say that our surface in three-dimensional coordinate system will be traced along the missing variable, which means that the missing variable can be any value. So in this case, you will see that it will be traced along variable z. And then I will end up having this dotted line, where this dotted line is parallel to the missing variable z. And then I will end up with this type of cylinder. And we call this cylinder as circular cylinder. The reason why we name it as circular cylinder, because the base of the cylinder is actually represent circle. Okay, this is what we call as circular cylinder. Okay, let's try this question. For example, if I'm asking you to sketch y squared plus z squared is equal to 36 in three-dimensional coordinate system, what kind of cylinder you will end up with given this equation or expression? So basically, if you don't have any idea on how the surface will be formed in 3D, sketch it in 2D first. So in 2D, again, you will end up sketch only two variables, but this time around, the variables I'm going to put and label in this two-dimensional coordinate system Z versus Y. Alright, so in this case, I will know that I will end up with a circle with radius 6. If I try to illustrate in three-dimensional coordinate system, I have z-axis, y-axis, and x-axis. Alright, so you sketch the base first, and the base is on YZ plane. So you have this circle, and according to our understanding, the missing variable in the given expression is variable x. Therefore, it will be traced along variable x. So you will end up getting a cylinder, and this cylinder traced along variable x. So that's how you sketch the circular cylinder. So I really hope if I'm somehow change the expression or tweak a little bit in terms of the question to you, by right, if you get the correct, or if you have strong foundation, you should be able to answer the question. Okay, we have discussed about circular cylinder, but what will happen if you are given with this equation, such as for x squared plus y squared is equal to 16, and the question asks you to sketch in three-dimensional coordinate system. So you have to be able to transform it in the form you are familiar with, because right now, previously, we know that x squared over x squared, a squared plus y squared over b squared is equal to 1 will always represent general equation of cylinder in three-dimensional coordinate system. So you have to transform the expression given to you in this general equation. So I have to divide the whole equation with 16. I will get x squared over 4 plus y squared over 16 is equal to 1. In this case, b is greater than a, such as b is 4 and a is 2. So you will end up with ellipse in 2D. In 2D, you will end up with ellipse, and this ellipse will be measured at y-axis because the value of b is greater than the value of a. And then, so you should end up getting this shape instead. Alright, so let's try to project the curve in 2D onto surface in three-dimensional coordinate system. Therefore, in three-dimensional coordinate system, I have z, y, and x-axis. Alright. So I will end up getting this cylinder, and we call this cylinder as elliptic cylinder. Reason being, the base of this cylinder is actually an ellipse.